And welcome to another episode of STEM in Seconds. Today I'm going to do a quick intro into trigonometry for right angle triangles. So here I've just got a basic right angle triangle. Here is the 90 degrees and this angle I'm going to label theta. This angle here would be 90 minus theta, but we don't need that now. This is the one we need to look at. The next thing I'm going to do is I'm going to label the sides. Now I haven't got any numbers here, so I can only give them names. The side opposite to the right angle, which is this one, we always call the hypotenuse, which I'm shortening here to hip. Now this is where theta comes into play. The side opposite theta I will refer to as the op, and this is the side adjacent to theta. So I've now given all of these sides names that relate to their position against this named angle. It's an unknown angle, but it's theta and it's very important. The hypotenuse is always the longest side. It is also always opposite the right angle. Now, because we are using a right angle triangle, the ratio of the hypotenuse to the opposite side to the adjacent side is very dependent on theta and only on theta. We can express this ratio as a function of x, and for each ratio of 2 we give it a special name, and these ratios are sine theta, cos theta and tan theta. Each of these expressions relates to the ratio between two of these sides. I have a handy little way of remembering which trigonometric ratio goes with which side, and my little mnemonic is called SOHCAHTOA. Slightly difficult to pronounce, but it will make sense in a minute. As you can see, I've written each of the 3 letters in a triangle. This helps make rearranging an equation a lot easier. This stands for sine theta equals opposite over hypotenuse, in the same way that cos theta is adjacent over hypotenuse and tan theta is opposite over adjacent. You can start to see why I've given them 3-letter abbreviations. If you're a bit confused, don't worry. We're going to do a couple of worked examples so you fully understand right angle triangle trigonometry. So here is my first example. As you can see, it is a right angle triangle. I've got a known side, a known angle, an unknown side, and an unknown angle here. This unknown angle doesn't matter, and in this case, because we have a known angle, theta is going to be 67. I'm trying to find x. So the first thing I'm going to do is I'm going to label my sides in relation to theta. Obviously this one is opposite the right angle, so that's the hypotenuse. This one is touching the angle, so it's the adjacent. And this one is opposite and doesn't touch the angle at all, so is the opposite. Now, I don't have any information on my hypotenuse, so I can ignore it. I do have information on my adjacent, and I'm trying to find out my opposite. So the 2 sides involved are my opposite and my adjacent. I then look up to these 3 and see which one contains opposite and adjacent, and in this case, it's tan. The side I'm trying to find is the opposite. So what I do is I use my thumb and I cover up the O in TOA. And this leaves me with tan times adjacent will give me the opposite. So x is going to be 26 from the adjacent multiplied by tan of 67, which gives me 61.3 to 3SF. Always write your significant figure numbers down. Trigonometry is fickle and most of the time you will not get nice numbers, so it's always good to put your reference. As you can see in my second example, I have 2 known sides and an unknown theta. Again, the first thing I'm going to do is label my sides with respect to theta. So this 12 is the longest side opposite the right angle, so is the hypotenuse. This 5 doesn't touch theta on either end, so is the opposite. And down here is the adjacent. As before, I don't have any information on one of the sides, in this case the adjacent, so I don't need to think about it. The 2 sides I'm dealing with are the hypotenuse and the opposite. Looking back up here, I see that it's the SO, which sounds a bit weird to say, but the SO that contains this, so sine theta is my opposite over my hypotenuse. Now in this case, I'm looking to find theta, so I can use this equation as it already is. Sine theta is going to be 5 over 12. Now that's all well and good, but I need to find theta, not sine theta. What I'm going to do to deal with this is apply the reverse function of sine to both sides, and that's called arcsine sine theta equals arcsine of 5/12. Now, since these functions are inverses of each other, they will cancel each other out. So theta is arcsine of 5/12, which gives me 24.6, again to 3SF. That's the end of this video. I hope you enjoyed my quick intro to trigonometry. Please comment any questions down below and don't forget to subscribe.